This is problem number 2 in the comprehensive part of the practice final. And these are the questions that are different from the questions that are from the previous midterm. So these are the ones we're going to discuss. And this is true-false. The statement is the hydrogen bonding interactions in water are about twice as extensive as they are in ammonia. And this is a pretty straightforward thing. We just have to draw the molecules, and it's pretty much self-explanatory, because a water molecule has 2 lone pairs on the oxygen atom that's bonded covalently to hydrogen. There can be 2 hydrogen bonding interactions with water molecules, whereas with ammonia, there's only 1 lone pair. So if we illustrate the hydrogen bonding interaction here, there's only 1 such lone pair to engage in hydrogen bonding interactions, so there's obviously twice as much hydrogen bonding interactions with water as there are with ammonia. And it's reflected in the boiling point of these compounds, the dramatic difference. They have about approximately the same molecular weight. This is 18 grams per mole, and for water, and ammonia is 17 grams per mole. And so they're traveling at the same speed, and they're both polar molecules, so they have London dispersion forces. They have dipole-dipole interactions, which are going to be comparable. And the big distinction here is this has twice as many hydrogen bonding interactions in the boiling point of water, 100 degrees Celsius, the normal boiling point in 1 atmosphere. And for the boiling point for ammonia is equal to minus 30 degrees Celsius. And this can really be clearly understood when you take into account the hydrogen bonding interactions, which is the only major difference, and it has that much of an impact. Hydrogen bonding interactions is significant. So this is indeed a true statement. So you would fill in the bubble on your scantron. It says A, or true. Now, problem number 6 is another one about intermolecular forces. And London forces are the induced dipole interactions. And these are very weak. They have a range of around 0.05 kilojoules per mole to 40 kilojoules per mole. And this depends upon the size of the molecule. For big molecules, there's a lot of surface area, and therefore, when they come into contact, there's going to be more induced dipole interactions. And so, with very large molecules, you can have a 40 kilojoule per mole type of a interaction. That's London forces. So, now, ion forces. This is what's responsible for salts forming together, and this is an ionic bonding interaction. This is not an intermolecular force. This is a bonding interaction, and this has a magnitude of around 400. This is around 400, 4,000 kilojoules per mole. So the magnitude is clearly, ion-ion forces, a bonding interaction, is much, much greater than the weakest of the intermolecular forces. So this is clearly false. So you should have, probably known that. You probably knew that already, but just in case, yeah, if this was your intuition was sound as a pound. This is not. This is not larger than this. So this is clearly false.